Problem 1.1.4a. The equation s cubed plus t cubed equals -3 relates the variables s and t. Using this relationship, which of the following is true? And then it has everything listed. It has either s is a function of t or it is not a function of t, and t is a function of s or it's not a function of s. So we have to figure out both directions on this. All right, so when we look back at our textbook, 1.1.1, that gave us this definition of functions. Basically, it's telling us the term function is defined using words like relationship, operation, or rule. In any case, a function must describe a well-defined dependent relationship between two sets of objects. There can be no question as to how the elements in one set depend on those in the other set. The standard notation b equals f of a, that's saying b is a function of a, indicates that the values for b depend on the values for a. Every value for a determines a unique value for b. I want this to be predictable. We don't like unpredictable things in mathematics, right? I want to, if I plug in a 1, I want to get out the same value every time. For example, if I plug in a 1 to a function and sometimes it gives me a 5 and sometimes it gives me a 7, then that's bad. That is not a function. I want to always have a predictable output. All right, so looking at our equation this way, I want to write s is some function of t, and then t is some function of s, if I can. Right, so let's start with trying to write s is a function of t. Well, my first step is going to be to scoot the t cubed to the right side. So I now have s cubed by itself, so s cubed equals -3 minus t cubed. Okay, then I have to get rid of the cube, and the way to do that is to take the cube root. That will then give me s equals the cube root of -3 minus t cubed. I don't have to put plus minus or anything like that. Now if I try to write t equals some function of s, again I start with the same kind of step. T cubed equals -3 minus s cubed, and then take the cube root. T is the cube root of -3 minus s cubed. So both are functions of each other. So choice D is going to be the answer to this one. D says s is a function of t and t is a function of s. All right, now things would change if we had one of these variables to an even power. And I happen to copy one of those as well, so let's take a look. If I have, and I just wanted to recall real quickly, if I have something like x squared equals 4, remember that when you go to take the square root, you have to put plus minus. Now I don't do that if the square root was already written on the paper, but because I am taking the square root, I'm making that change, I have to put plus minus in front of that. So I take the square root of x squared, I get x, square root of 4, but I have to put plus minus one place or the other. So I either would say x is 2 or x is -2. There are two possible answers to x squared equals 4. All right, so with that in mind, let's take a look at this problem. This one says the equation p cubed equals r squared relates the variables p and r. Now, which is true? Okay, so this exact example, p cubed equals r squared, just happens to be in your textbook. So let's take a look at our textbook. This is in 1.1.4. Now 1.1.4 corresponds to the question number we were looking at. And here is this exact question. In the example, the equation p cubed equals r squared relates the variables p and r. First, let's try to solve for p. Decide p is a function of r. So they take the cube root of each side, and they get that p equals the cube root of r squared. Well, that's okay. That's a function. And they happen to mention, hey, what if r is 8? Well, then I would square the 8 and then take the cube root. I would get 4. That's all good. There's only one possible answer to that. But what if we try to solve the same equation, p cubed equals r squared, for r instead? Well, we start with p cubed equals r squared. When we try to get the r by itself, we take the square root. And because we are taking the square root, it wasn't already written on the paper, and 2 is an even number. This happens every time you take an even root. You have to put plus minus. It's no longer unique now. That's two different equations. I have the positive square root of p cubed, and I have the negative square root of p cubed. So r is not a function of p. R is not a function of p. All right, so looking at that problem, you can see that the answer is p is a function of r, but r is not a function of p. I hope that helps you understand 1.1.4a. Watch for things like squares and fourth powers and sixth powers. If we did trig in this class, you would watch for things like sine and cosine. Okay. All right, hope it goes well.